So this is section 7.3 in pre-calculus. We're going to continue on with the sine and cosine graphing. So we've learned the basic graph of sine and cosine. We've learned what the A number out in front, what the amplitude does. Remember, it stretches it vertically. And so we're going to continue on and look at some of the other letters. So remember the standard form for a trig graph. And since I used the sine function when I was writing the standard form, I think this time I'll use cosine, because remember it's the same thing for both sine and cosine. So you might have some A number out in front, and then your trig function, I'm using cosine, and then there could be a B number in front of a parenthesis. In the parenthesis would be x, either plus or minus some C number, and then out at the end you can add or subtract another number that we're going to call D. So today we're going to focus on this D number and what that does to the graph. Well, actually, you've used this idea before, this adding a number at the end. Remember back in Algebra 2 and Pre-Calculus when we did all of the function transformations with parabolas and square root graphs and rational functions and absolute value functions. So say, for example, you have the graph of y equals x squared. Okay, we all know that's a basic parabola. Vertex is right there at 0, 0. Well, what would happen to the graph if we put like a +1 at the end? Well, wouldn't the entire parabola just be moved up 1 unit? So the same basic shape just moved up 1 unit. Or maybe if you put a -2 out at the end, wouldn't it be the same basic parabola just shifted down 2 units? So that number at the end shifts the graph either up or down, and so that's why we call it a vertical shift. So the D represents a vertical shift. A vertical shift, and it moves the graph up or down. It doesn't stretch it, but it will shift. There's a difference between a stretch and a shift, okay? A shift moves the entire graph up or down. Notice when we did amplitude, when we did a stretch, it didn't change the zeros. All it changed was the max and min numbers. Okay, so this says, sketch the graph of y equals sine and then y equals sine of x plus 2. So let's start with y equals sine. So remember the sine graph. It starts, ends, and halfway at 0, it goes up to 1, and it goes down to -1. I'm going to go ahead and write this. Remember how we said our units are always going to be a half pi? So that would be 1 pi, and that would be 2 pi. So the basic sine graph looks something like this. There's your basic sine graph. Okay, well, if the +2 at the end is going to shift the entire thing up 2, that means every single one of those 5 points is going to be moved up 2 units. So that first point's going to go up to here. You can move it in whatever order you want. I like to move them in the same order that I normally graph the sine function. So I'll move the first, the last, and the middle one. Again, I'm not saying that you have to do it in this order. I think it'll make your graph much more accurate. So you know what? You can take that advice for what it's worth, and I'll just count it wrong when you mess it up. Okay. And then this point right here that was at 1, it was now moved up. And then this point that was down here at -1, oops, let's see, we're moving them up to, yeah, so that's going to move up to right there. And so when I draw this graph, it should look like the exact same graph, but just moved up 2 units. If I wanted to, just to kind of show you, if I were to grab a hold of, well, I guess this whole thing, I can't get the whole thing. If I were to just shift the whole thing up, do you see that it should look like the exact same shape, just moved up? Okay. So let me label. This one was sine of x plus 2, and remember this blue one was just the basic sine of x. Okay, so let's go down to this. Let's do the same thing with cosine. So let's graph the basic cosine. So remember, cosine normally starts and ends at 1. So start and end at 1. Halfway I'm at -1, and then remember halfway between each of those we were at 0. So if I'm going to draw the basic cosine graph, something like that. Remember, I still curve all the way through. Then if I'm going to take every single point, this time notice it's a -2, so I'm going to move every single point down 2. So where I started and ended at 1, that point comes down here to -1. Where my halfway point was -1, now it's down here at -3. And then these are going to come down by 2, so they're going to be kind of right here in the middle. I just like doing it this way because I can kind of tell when I line them up. You see how those points are still lining up in a V shape? And then when I draw that same shape, so it should look like the exact same shape, just moved down 2 units. Do you see how every single point, again, you don't have to draw all these arrows in, but every single point was just moved down 2 units. So this one was the sine of x and then -2, where the blue one was the sine of x. Okay, notice every time I draw multiple graphs on the same set of axes, I always label them so you can know which one's which. Okay, so what if we put everything together? Let's put together the concept from last time, the amplitude, with the vertical shift. All right, so number 3 says, without using your calculator, sketch the graph of y equals cosine and y equals cosine plus 1 on the same set of axes. Then sketch y equals cosine and cosine minus 2 on the same set of axes. Okay, so I'm going to put these two that are in blue on the same set. So cosine starts and ends at 1, halfway at -1, halfway, and it may sound tedious, but it should take you just seconds to draw that basic cosine graph. And then I'll put cosine plus 1, so everything goes up 1 unit, everything up 1 unit. So again, even though it may look like we're doing a lot of repetition, it takes seconds to draw these, right? Cosine plus 1, and that one was cosine, all right? And then it said, now why don't you put cosine and cosine minus 2 on the same set of axes? Okay, cosine, start and end. Come on, I need some color here. Start and end at 1, halfway at -1, halfway at 0. Basic cosine. And then it says cosine minus 2, so everything is moved down 2. This is the exact same one we did a minute ago, isn't it? Everything is moved down 2, down 2. Do you see how by doing that I can kind of make sure those points kind of line up in a nice neat V? This one was cosine minus 2, and remember this one was the basic cosine. Okay, so look at number 4. We're putting it all together. Now we're going to do amplitude and vertical shift. So here's what I suggest you do. When I go to graph this function, okay, let's do it in 2 pieces. Okay, I want you to do this even on your homework. I want you to do it in 2 pieces. Don't try and go all the way to the end. Humor me. Let's start with the amplitude. We'll see what that comes out to be. So ignore that -1. Let's just graph 2 sine of x. So let's see. Sine of x starts, ends halfway at 0. If it has an amplitude of 2, that means it goes up to 2 and down to -2. So this is the graph of the sine function with an amplitude of 2. That's just 2 sine of x. Okay, that's just 2 sine of x. Let me put that right up here. Okay, now let's bring in the -1. Well, that's going to take that 2 sine of x graph and move everything down 1. So these middle points, the start, end, and halfway, are right here. If I bring this maximum point down 2, down 1, it's going to be right there. And if I bring this minimum point down 1, it's going to be right here. So here's my 2 sine of x, but all moved down 1. So this is 2 sine of x, everything moved down 1. So again, can you tell? Basically, I took the 2 sine graph, and every single point is just moved down 1 unit. Okay, so the final graph is the red one. But I want you to do both of them just to make sure it's accurate, just to kind of get this in your head. All right, so I'm going to start with just the amplitude, the 3 cosine. Let's see, cosine. It starts and ends at, since the amplitude is 3, it's going to start and end at 3. Right? Halfway it's at -3. and then halfway between each of those it's at 0. So just the cosine with an amplitude of 3 does something like that. So there is 3 cosine, and now I'm going to move every point up 1. So I'm going to start and end up here 1 more unit up. That minimum is going up 1. The zeros are going up 1. So it's going to be that same basic shape, just moved up 1. So that's my 3 cosine, but with a plus 1. Okay? Let's go to letter C. Again, I want you to be consistent. Let's always include the amplitude, the A number in the first graph, and then after we get that, we'll move all of those 5 points either up or down. All right, so negative sine. So let me think. The sine function starts, ends, and halfway at 0. Where normally it goes up, because it's negative, it's going to go down first. So there's my negative sine. So this is negative sine. And now I'm going to take every one of those points and move it up 2. So the zeros are now up here at 2. The zeros are now up here at 2. Okay, let's see. This one's going to go up to negative 1. This one's going to go up here. And so there is my sine graph. I don't know why it takes me a couple of them to get the one I want. There is my sine graph moved up 2. So negative sine up 2. Again, notice, even though I'm doing 2 graphs, I'm labeling each one to show what's going on. Okay, letter D. I'm going to start with the amplitude part. So let's see, cosine. Cosine, it normally starts and ends at its max. Because it's negative, I'm going to start and end at a half, negative 1/2. Halfway, it's going to be over here at positive 1/2. Halfway between each of those, I'm at the zeros. So here's my cosine graph kind of squished up a little bit. Okay. So that is the negative 1/2 cosine. And now I'm going to take every one of those points and move it down 2. So down 2 would be right here. And even though it's a half, I can still get it to 2.5, negative 2.5. Right? This one's going to be lined up over here. This one, if I come down 2, 1, 2, it's going to be like right in here. I know it's a little harder because I don't have the grid lines, but you know what? Suck it up. It's not that bad. And then this one's going to come down 2, so right here. This one's going to come down 2. Notice it helps moving those points in the order that we graph them, because now I can kind of make sure that this point is kind of lined up in the middle of where these are supposed to be. And so I'm going to have that same basic shape, right? It's kind of squished up. And so that is my negative 1/2 cosine, and then minus 2. Okay? So that is section 7.3 that brings in amplitude and vertical shift. That makes it a little bit more interesting.